Okay, so welcome. And so in this video we're going to carry on with our work on deriving the formula for finding the surface area of rotation. So finding the area of this of a surface of rotation. And so I drew this picture. So again, remember we have this line segment and we're rotating it around an axis of rotation. And so what we're going to end up getting is something that looks like a part of a cone where the top is cut off. And so I drew a picture here where we have the bottom radius R1 and the top radius R2 with this length, the slant length here. And so what we're going to do is we're going to use this to help us to derive the formula, because we're going to compare this to a cone. Okay? Because we know the lateral surface area of a cone is pi rs, which is pi times the radius of the base times the slant height, which is s. So we can find the surface area of a cone by taking the base, the radius of the base times the slant length of the cone and pi. Okay? So, but we don't have a full cone. So what we can do is we can have a full cone, and let's treat it like that we have this cone, and we just cut off the tip of the cone, which is, the tip of the cone is still a cone. So what we can do is we can treat this as the lateral surface area of one cone, the whole cone, minus the lateral surface area of the tip of the cone, which is still a cone, subtract those two. So what we could do is we could set up, okay, the surface area, lateral surface area could be done with this. So here's the setup. So I could do pi r1, right? So I'm going to do the larger one minus the smaller one. So pi r1 s minus pi r2 times S minus L. Okay? But here's the thing. If this is what we have, we don't know what S is. I mean, there's no way we can extrapolate. I mean, we could, but I mean, that we'd have to know more information, but to extrapolate that to a point to find S. So what I'd like to do is get rid of S and see if we can rewrite S in some other way, okay? Do a substitution. In fact, what I'd like to do is replace S in terms of R2, R1, and L. Maybe there's a way to do that, and there is. So let's look at this cross section here. So the cross section here makes similar triangles, right? So let's see what that gives us. So if we look at similar triangles, we know we can set up a proportion. So we could say, how do I want to do this? I want to make sure. Let's do R2 to R1. Is equal to S minus L over S. Oops. And now what I want to do is solve for S. Okay, so let's play around with this. So let's solve for s. So I'm going to get s times r squared over r, not r squared, r2 equals, and I'm going to multiply by r1 too. So let's get rid of the r1 and the rs. So let's multiply by s on both sides and multiply by r. So I'll get s r2 equals r1 times s minus l. Okay, so now let's distribute the r1. So we're going to get s r2 equals s r1 minus l r1. And now I'm going to bring this over to this side. So let's bring it here. So I'm going to say this is s times r2 minus s times r1 equals negative l r1. And now I can factor out the s. So I get s times r2 minus r1 equals negative l r1. And now I'm going to divide, and I get s equals negative l r sub 1 over r2 minus r1. Now what I can do is I can absorb the negative, right? I don't want that negative out there. So I can distribute the negative in the denominator and just flip these. So I'm going to write this as L r sub 1 over r1 minus r2. And so that is what I'm going to use to substitute in for my formula. So I'm going to substitute in for s here. Okay? So what do I get if I do that? So I'm going to get pi r1, and then s is going to become and then minus pi r2. I'm going to run out of room. Well, make sure you write this down. I'm going to erase. You know, let me write it over here. So what I'm going to get is this here is going to end up being pi r1 times LR1 over R1 minus R2 minus pi R2, and this is going to be LR1 over R1 minus R2 minus L. Okay, so now I got rid of the S's. So now I've got my formula in terms of the three things that I'm going to know. I'm going to be able to know the radius 1, I'm going to be able to know this one, and I'm going to know this one. Right? Because that's what I'm going to use for the arc length. Okay? So now, we simplify this thing. Okay, well let's simplify it. Okay, again, I'm going to erase this, take notes. I'm going to erase this because now I got everything in here. So this is my formula, right? This is the formula I want to use for finding the surface area of rotation of this thing. Okay, now we just need to see if we can make this into a nicer, simpler form that we would like to work with, because the way it looks right now, I don't know if I'd want to work with that. In fact, I know I would want to work with this. So let's see if we can simplify things. So, first of all, let's factor out the pi, and then let's distribute the r here, so that's going to be, because I don't have, yeah, let's distribute the r. So r1 squared over r1 minus r2 minus, this is going to be r2 r1l r1 minus r2 minus L R2. Actually, I'm going to distribute, so this should be negative, this should be positive. So I factored out the pi, and I distributed the r here and the r here. And so I get this minus this plus that. Okay? So, what do we want to do now? Well, now we want to get a common denominator. So let's do that. Okay, and so now let's combine these into one fraction. You want to do that? Let's see here. Oh, let's see here. Do I want to do that again? Yeah, let's do that. I don't think it'll matter. Yeah, I want to distribute this too, so let's do that. So pi, and you know what, I have an L here too. I can factor out the L too, so let's factor out the L. And so now I get R1 squared minus R squared R1 plus R2 R1 minus R2 squared over R1 minus R2. Okay? Now again, the textbook, if you look at different textbooks, you can write it differently. Okay, and so let's simplify this. We get pi L. And so what happens here? Well, look at this. We get minus this, and then we plus this. So these are going to go away. So what do we end up with? We end up with R1 squared minus R2 squared. That's interesting. Over R1 minus R2. Okay, well, that's good. Well, of course, this is the difference of two squares, so we can write this as pi times L, and we're going to say this is going to be R1 minus R2 times R1 plus R2 over R1 minus R2. And now R1 minus R2 cancels, and we end up with pi times L times R1 plus R2. And that's the final answer. Okay? So this is the formula for finding the surface area of a frustoon. And so now let's use this formula to calculate the surface area of each of the bands formed. So remember, in the last video, we had a bunch of line segments that we're going to rotate around the x-axis or in an axis. So we just found the formula to find the area, surface area of rotation for one of those. So now we're going to put together and say, okay, well, if I have n of these things, right? N of these segments that I'm going to do that for, well, then I get to sum up all of those surface areas, and I get the approximate surface area for the curve. And of course, then the next step obviously is logically to say, hey, what if we take the limit of this summation as n, or in other words, the number of subintervals goes to infinity, and then we have our integral. So let's see how that works. So we'll do that in the next video.